Okay, today we're going to talk about sum and difference formulas. Now, sum and difference formulas, we're going to learn how to use them to evaluate trigonometric functions, verify identities, and also solve some trigonometric equations. So let's take a look at these equations. Now, I'm not going to go and derive these for you or anything like that. We're just going to go ahead and use them. So let's take a look at them. Sine of u plus v, so sine of something plus something else, okay, is going to equal sine of the first times cosine of the second plus cosine of the first times sine of the second, okay? So you can see this kind of weird structure going on where we have sines, cosines, first, second, cosine, sine, first, second. So we keep the firsts and the seconds lined up, and then we swap cosine and sine, but we keep the sine in the middle the same as the sine in the middle here in our original function. Now let's go on to the cosine sum and difference formulas. Here we have cosine of u plus b equals cosine u cosine b minus, so the signs are opposite in this one, sine u sine b. And then we can see that the minus version of this also flip-flops, okay? Then finally we have tangent of u plus v. That equals tangent u plus tangent b. So these signs are the same, over 1 minus tangent u tangent v times tangent b. So these two are added, these two are multiplied. These signs are the same, these are different. And then the signs flip-flop, but not the order of things, for the difference formula for tangent. So we'll put a poster up with these up in the classroom so that you can get used to them, but I highly recommend that every time you feel the need to use one of these, you just write out the formula and it'll help you memorize it a lot quicker. So let's first start with evaluating some trig functions. If we want to find the exact value of something like cosine of pi over 12, and we don't really know an exact value for that, there's a way to calculate it using our sum and difference formulas. Now we have to first realize here that pi over 12 is equal to pi over 3 minus pi over 4. So then our problem really becomes cosine of pi over 3 minus pi over 4. It's a minus. So using our cosine formula, and remember our cosine formula is cosine of u minus v equals cosine u cosine v plus sine u sine v. Okay, so now we're going to set this up. Our u is pi over 3, our v is pi over 4. So we're going to have cosine pi over 3 times cosine of pi over 4 plus sine of pi over 3 times sine of pi over 4. Okay? So cosine of pi over 3 is just 1/2. Cosine of pi over 4 is square root of 2 over 2, not square root of 3 over 2. As soon as I said it, I knew it was wrong. And then sine of pi over 3 is square root of 3 over 2. Sine of pi over 4 is another square root of 2 over 2. So when we multiply these fractions together, we get square root of 2 over 4 plus square root of 6 over 4. And we can simplify that by just saying square root of 2 plus square root of 6 all over 4. Now we can also do a little bit easier version of this. Say we want the exact value of cosine of 45 times cosine of 15 plus sine of 45 times sine of 15. Now, I don't know how you'd ever run across this, but in case you do, hey, we have a formula for that. And we can see that this is going to be the formula cosine of u minus v. So that will equal the cosine of 45 degrees minus 15 degrees, which is the cosine of 30 degrees, which is square root of 3 over 2. So this problem really isn't, in its present form, really useful for you, except to note that if you want to calculate something like cosine of 15 or something like that, you could use a problem like this, or a format like this, I should say. So just think about it in case you run across needing to solve for an exact value of something that's some sort of combination of special values that you would already know. So now let's look at another application of this, and that's writing things as algebraic expressions. So we want to write the sine of the arctangent of 1 plus the arc cosine of 1 as an algebraic expression. Okay? So we're doing sine of something plus something, so I'm going to use my sine u plus v equals sine u cosine v plus cosine u sine v. That's my formula. And in this case, my u is arctangent of 1, and my v is arc cosine of x. So this will be equal to sine of pi over 4, because the arctangent of 1 is pi over 4, plus arc cosine of x. Okay, so that's rewriting it. So that will give me sine pi over 4 times cosine of the arc cosine of x plus cosine of pi over 4 times the sine of the arc cosine of x. Okay, now sine of pi over 4 is just square root of 2 over 2. And the cosine of the arc cosine of x is just x. Cosine of pi over 4 is square root of 2 over 2. And now we've got to figure out an expression for the sine of the arc cosine of x. So if I look at x in the first quadrant, and knowing that cosine is adjacent over hypotenuse, this is going to be x over 1. Finding this missing side length for me is going to be 1 minus x squared. That's using my Pythagorean theorem. So this height here will be h squared plus x squared equals 1 squared. So h squared equals 1 minus x squared, and h will equal the square root of 1 minus x squared. That's how I figured that out. And now recognizing that sine of this angle is going to be opposite over hypotenuse, I can rewrite the sine of the arc cosine of x as the square root of 1 minus x squared. Okay, so rewriting this all to be over 2, I have x radical 2 plus radical 2 times the square root of 1 minus x squared, and factoring out a radical 2, I could just say it's radical 2 times x plus radical 1 minus x squared all over 2. It's all good. A lot of different ways to write this. You kind of almost don't know where to stop. Now we're going to prove this cofunction identity. We're going to prove that sine of x minus pi over 2 equals negative cosine of x. Okay? And that's one of the ones that we were given a while ago, but using our sum and difference formulas, we can actually prove this to be the case. So we're going to use the formula sine of u minus v equals sine of u cosine v minus cosine u sine v. So this will give me sine of x minus pi over 2 is equal to sine x cosine of pi over 2 minus cosine x sine of pi over 2. Now, cosine of pi over 2 is just 0, so that zeroes out this whole term. And sine of pi over 2 is 1. So with our negative sign here, we will just have a negative cosine x. So that was a really short proof for us. Next, we're going to simplify tangent of theta minus pi over 4. So we're going to use our tangent of u minus v, and that will equal tangent u minus tangent v over 1 plus tangent u tangent v, okay? That's going to be our formula. We're just going to plug things in and simplify where we can using the techniques we have already learned. So we will have tangent theta minus tangent of pi over 4 over 1 plus tangent theta times tangent pi over 4. Now, tangent of pi over 4 is 1, so we're left with tangent of theta minus 1 over 1 plus tangent of theta. And that's how that simplifies. Another easy one. Now let's look into solving some trig equations, and this should read equals. And we're going to do this over the interval from 0 to 2 pi is where we're going to find our solutions. Okay? So we have a couple different formulas that we're going to have to use. We have a minus and a plus in here. So I'm going to write my sine formula in a very compact way for you. I'm going to say sine of u plus or minus v equals sine u cosine v plus or minus cosine u sine v. Okay? So this indicates to me that if I'm looking at a plus, this sign over here will be plus. If I'm looking at a minus, this sign over here will be minus. It's because I'm going to need both of these. So here's my first u, here's my first v, here's my second u, here's my second v. So I'm going to have to apply this formula twice. So I will end up with sine x cosine of pi over 2 plus cosine x sine of pi over 2. Now the second plus comes from the equation, and we'll use the bottom version or the minus version of our sine formula again. So we'll have sine x cosine of 3 pi over 2 minus cosine 3 pi over 2 sine x, and that will all equal 1. Okay, so now let's see what we can simplify. Cosine of pi over 2 is 0, so that negates this whole term to 0. And cosine of 3 pi over 2 is also 0, so that negates that term to 0. Now, sine of pi over 2 is just 1, and sine... Oh, wait, I switched the order of these, I just noticed. This should really be cosine of x and sine of 3 pi over 2. Okay, and the sine of 3 pi over 2 is a negative 1. Okay, so now we're left with cosine of x minus, and it's negative 1 times this negative cosine x, so it'll be plus cosine x equals 1. Hope everybody saw that. So that gives me 2 cosine of x equals 1. Dividing both sides by 2 to isolate our trig function, we get cosine of x equals 1/2. This is a positive 1/2. Cosine is positive in the first and fourth quadrants. And it equals 1/2 for pi over 3 and 5 pi over 3. So there are our solutions for this particular function. Lastly, we're going to verify a difference quotient with trig functions. Okay, so here we have cosine of x plus h minus cosine of x all over h. And we're going to use our cosine function. So cosine of u plus v equals cosine u cosine v minus sine u sine v. That's going to be the formula that we're going to use for cosine of x plus h. So this is going to look like cosine x cosine h minus sine x sine h minus our other cosine x from here all over h. Okay. Now two of my terms have cosine of x's. Okay, so I'm going to reorder those terms so that you can see what it will look like when I factor things out. So I'm going to put my minus sine x sine h term off to the side here, and then I'll have a positive cosine x cosine h and a minus cosine x. I'm going to factor out a cosine x from these two terms right here. I don't have to factor from all my terms. I'm going to have a negative sine x sine h plus cosine x. And when I factor cosine x out of each of these two terms, that is going to leave me with a cosine of h minus 1. And all this is over h. Now, this part of things can be broken up to look like this. So I can rewrite this as cosine of x times cosine of h minus 1 all over h. And then I can look at this part of things, right, because this is also over h. So that's minus sine x times sine h over h. And now my sides all look like the right-hand side up here. So we haven't really learned any new tricks or anything like that. I've just shown you how to use these formulas, okay? So we're looking for things like factoring. We're looking for ways to simplify things using values of sine and cosine for special angles that we already know. We're looking for anything that can help us simplify, and then we're doing the best we can with that. So using the sum and difference formulas, your trickiest part is just going to be memorizing them and writing them all down every single time. But other than that, things should be pretty good. That's it for today.